Opop, we have a very useful video today. It should have been made 2 or 3 years ago when we first started making videos about engines. When remember we filmed about the E46 and the M57 Diesel, that was when we should have filmed about this engine. As you might have guessed, this is the M57, which is a 3-liter diesel. The super mega engine of the year, dating back to the 2000s. It was installed in a lot of cars, and we've gathered a few for you, which are now behind me, several modifications. I think everyone will find it interesting. Get your popcorn ready and let's go. Well, why not prolong the review of the M57? Because this 3-liter diesel is still relevant. And right now, our country is at war, facing significant fuel shortages, especially with gasoline. Diesel cars, as you understand, have better fuel efficiency, making them very relevant at the moment, since you can drive about 1,000 kilometers on one tank, which isn't possible with gasoline engines. At this time, even our manager from Predecessor, Dmitriy, who is currently temporarily managing in Lviv, bought an E91, which is behind me, a 325 diesel with the M57 engine, to save more on fuel, and that's why we're making this video for you. So, there's another candidate for the spotlight. Well, we can talk about it. Secondly, we are currently in Lviv, which is about 70 kilometers from the border with Poland in the west of Ukraine, and diesel engines are very popular here. There are a lot of cars imported from Europe. There aren't as many American cars, but there are still quite a few. However, alongside American cars, European cars are also widespread. By the way, before American cars became popular, there were a lot of cheap European cars with no customs clearance brought in from that side. 5 or 10 years ago, the most popular engine here was the M57 and also the M47. So there are a lot of them here, and overall they are still relevant. So I think many will find it interesting and useful to learn about this engine and how great it is and so on. The M57 engine was produced from 1998 to 2012. Imagine such a successful engine that it had a bunch of different modifications and was produced for such a long period. The first body it was installed in was one of our longtime favorites, the E39 530d diesel. And there was the E46 with the 330 diesel, as well as the pre-facelift E53, which had the first modification. These cars started coming to us a few years ago when we were still in double garages, and we often saw them. There were often various problems. So we've gathered one of those cars for you. Here we have the E39 530d diesel, which was probably the best seller of that time, meaning in the early 2000s. It was the most popular BMW sold and produced. The first modifications had 193 horsepower. Then came the M57N modifications. They were already installed in the latest version of the E46. Then it was installed in the facelifted E53, on the E90s, pre-facelifts, and on the pre-facelift E60s. In short, it was in these models as well as the later E-series. Especially in the last E-series, they were present in pre-facelifts. After that, the M57N2 came along. For example, we have one E91 here, which is a 325 diesel, pretty much the same as the 330 diesel, the M57N. Then we move on to the top versions, the M57N2, including the top 1 and top 2. There were also the most highly tuned versions of the M57 engine, which were twin-turbo versions. For instance, in the pre-facelift E65 535 diesel, there was a cast-iron block, which was the M57N version, with a cast-iron block and 2 turbos. This version was called Top 1. Later, we had the E70s in Europe and the Americans, which had aluminum blocks. There, the M57N2 Top 2 was present. By the way, we also have a cool car behind us, an E91 335 diesel, which has the M57N Top 2 version engine. Specifically, ours is a true 3, but we'll talk about that at the end of the video. In the M57N and N2 versions, the power ranged from about 218 to 245 horsepower. In the twin-turbo versions, the power was about 272 horsepower in the pre-facelift E60, and in the facelifted European E60, E70, and E90, it was 286 horsepower. As for the American models we mentioned earlier, the E90 335d diesel, there's a cut-down version that was modified for environmental standards because American cars always have to have AdBlue installed. It has 252 horsepower, but this can easily be increased with a chip, just like the European versions, to around 320, 330, or even about 340 horsepower. In summary, we've covered the main versions of the M57 engine. Now let's start with the first version, the most popular one 10 years ago and 5 years ago, when we were just beginning to open our service station. There was a boom in cheap European cars with no customs clearance in Ukraine, and this was by far the most popular engine, the most popular BMW that was coming to our garages and small shops back then. This is the E39, produced from 1998 to 2003. Let's take a look at the engine. Our review will be similar to the one we did on the M47 and the E46 body. Here's the link, check it out. We'll follow our usual template for engine reviews. As always, we start with the iron. Here we have the first version. This is like the million-kilometer engine, the one that won Engine of the Year for almost 5 years in a row. It has a cast iron block, and this engine can easily go 600,000, 700,000, or even 1,000,000 kilometers. These are the cars that have a lot of mileage. If you see, for example, an E39 with 170,000 or 250,000 kilometers on the clock, know that it's probably been wound back 10 times. And in reality, it could have 600,000 or 700,000. If you think your E39 engine is being stressed, it probably has over 500,000 kilometers on it, and there could be any number of issues that arise. It's the top engine, the most reliable. This engine marked the beginning of the glory era for BMW engines. It was so cool that it was also installed in Opels, including the Omega. I remember being surprised when I saw one come in. That was in the early days of my career, probably within the first 6 months after opening the service station. It was also installed in Range Rovers. As for problems with the bottom and top of the engine, there aren't any, unless you have over 500,000 or close to 1,000,000 kilometers on it. Then there could be some issues. From what I've personally seen, the main problem has been a blown head gasket, but that was a Euroblecker. And again, it's unclear what the mileage was. So we probably won't discuss mileage too much in this video, because with diesels they can really last a long time, and it's hard to determine the actual mileage. It's difficult to gather statistics since this car isn't a new one. If we had a car that was bought in Ukraine from new and could track how it went to 1,000,000, that would be more objective. Here we won't talk much about mileage. Internally the engine is great. Externally there might be a slight leak from the oil pan gasket, with the mileage being unknown, possibly over 300,000 kilometers, you could say. There's also the crankshaft pulley, which is made of 2 parts. As you know from our previous diesel reviews, there's a torsional vibration damper, which is also the crankshaft pulley. And it consists of 2 metal parts with a rubber piece in the middle. Over time, that rubber cracks and tears due to the vibration of the diesel, and the pulley can come loose. So, the pulley needs to be changed definitely after about 300,000 kilometers. The oil pan gaskets, crankshaft seals, and valve cover gaskets, it's hard to say these are specific issues, because they can show up at mileage over 300,000, maybe even 500. You'll be lucky to find such a car. Now it's 2024, and these cars are already 20 years old. I think that's just absurd. Absurd. Once again, absurd. As you know from our previous videos, the reliability of BMW diesels is also due to the absence of interesting modifications found in gasoline engines like Vanos and Valvetronic systems. Diesel engines operate without these systems, so that's another plus for the engine's reliability. Overall, this video will be very similar to the one about the M47 engine, so if you haven't seen it yet, I highly recommend you check it out. We laid everything out very clearly there. If we compare it to the M47, in that video we mentioned cases of the crankshaft spinning. We even mentioned that one of our mechanics experienced this, but in the M57, that problem doesn't occur, even though its popularity seems just as high, considering the body types and the time period they were produced. I think the topic of BMW chains is well known to all our viewers. This definitely concerns the N20, N55, and the N47 engines. But what about the M57? I'll put it this way. In the early modifications of the M47, without the N and N2 engines, there were generally no significant issues with the chains. I believe that owners usually replace them after about 500,000 kilometers of mileage, or after 300 on the odometer, but in reality, some have even gone 600 or close to 1,000,000. So I think the chains here can easily last 500 to 600,000 kilometers. You just don't know what your current mileage is. Following our chronological discussion about engines, next is the air intake system. For this engine, this is neither an exception nor surprising because it is the most important system after the iron components, as this is a turbo engine, and there's a lot tied to this, with much to tell you. The intake system. Air enters through the air filter, which needs to be changed with every oil change because for turbocharged engines, the air filter is very significant in terms of both its throughput capacity and its filtration ability. That's why we usually change these filters with every oil change. Next, the air goes into the turbocharger, specifically for these M57 modifications. As far as I remember, a few years ago, when we were frequently chipping them, it was a popular service at the time. You could tune them from about 190 horsepower to around 220 to 230 horsepower. The maximum was around 240 horsepower on the stock turbo, but there were limitations both with the turbo and the fuel system. We'll get back to the fuel system later. The turbos last well. If you chip them too aggressively, of course, the turbo's lifespan decreases because its normal speed increases when pushed hard. In general, if your car is stock, everything will run fine, nothing will break, and the lifespan is significant, around 200, 300, 400, or maybe even more than 1,000,000 kilometers. Just give us a living example that has done that mileage, and that would serve as proof. The air is then compressed by the turbo and goes to the boost pipe, then to the intercooler, and then to the charge pipe. We explained this process very well in the video about the M47, covering geometry and vacuum control. It's a must-watch, so check it out as we'll skip this here to avoid unnecessary duplication. In short, it's recommended to check the vacuum hoses every 200 to 300,000 kilometers to see their condition. If you just bought the car, replace all the vacuum hoses that control the turbo, and we highly recommend changing the turbo pressure regulator. After these replacements, your 530 or 330 might perform like a hurricane, like a bullet straight from the factory. So if someone tells you that your turbo isn't boosting, then there's about 70 to 80% chance that the issue isn't with the turbo at all, but with the turbo management. We specifically discussed this in the video about the M47. Next, there's the boost pipe and intercooler. You often see condensation or oil droplets forming at the junction of the boost pipe and the intercooler. This can be related to several reasons. First, the rings at the junction may need to be replaced. This might help or it might not, as they can dry out with age. Second, there may be increased crankcase gases from the engine. If your piston rings are functioning properly, crankcase gases flow through the PCV system, go into the intake through the turbo, and oil gets carried along. This all travels the entire route to the intake and eventually re-enters the engine's intake. Thirdly, one common issue is that the turbo itself can leak oil. So the solution is to replace the PCV, replace the gaskets, and repair or replace the turbo. If none of that helps, you likely have increased crankcase gases in the engine. As you know, we have set up a space in Lviv called Lviv Turbo Service. Our team has experience diagnosing even crankcase gases with specialized equipment. This can help determine the extent of wear on your connecting rod and piston assembly. So if anyone is interested, feel free to book an appointment and come to our service in Lviv type. The boost pipe that goes from the turbo to the intercooler is partially metal and partially rubber. The rubber can get cut, break, and so on. So there could be issues there. Generally, there aren't many problems with the intercooler unless a stone gets lodged in it, or if your car has been sitting for many years and everything has corroded or deteriorated. But usually there aren't issues with the intercooler. However, there are problems with the charge pipe. It consists of 3 parts, metal in the middle and rubber at both ends. It's common for the rubber parts at the top and bottom to get cut or split due to pressure, among other issues. So this is one of the frequent components that need replacing on this engine. Now let's move on to our favorite intake. Now let's talk about our swirl flaps. Everyone knows about them. The metal ones can get sucked into the cylinder. Here, we recommend removing and blocking them off. A few years ago, this was a very popular procedure. We would immediately block off the swirl flaps. And the EGR, well, let's touch on the EGR right away. We would block off the EGR as well. All of this was done through software, plus we would chip the car and it would run perfectly. We recommend the same for our clients here. This intake usually doesn't get clogged as much as the N57, which is the next engine. So it's also advisable to remove it, inspect it, replace the gaskets between the cylinder head and the intake, and clean it up, as well as remove the swirl flaps. You could say it's a comprehensive approach. Next, we move on to the air passages in the cylinder head, known as runners. Well, usually there are no problems there. If nothing gets into them, then nothing will happen to your valves. Next, we'll talk about the exhaust system on these versions of the N57. Usually, there is a cast iron exhaust manifold, and there are no problems with it. If we're talking about the N57, it usually has a steel exhaust manifold, which often burns out and crumbles inside. It's replaced with a cast iron exhaust manifold or one from the M57N2, like those in our later models. A cast iron exhaust manifolds are already installed, preventing those issues. After the exhaust comes the turbocharger, as previously mentioned. Then typically, a diesel particulate filter followed by an intermediate catalyst. So at these mileages, it is recommended to remove it, as buying a new one would cost about half or a third of the car's value. Typically, owners of such cars just remove it altogether, and it's all deactivated in the software. Moving on to the injection system, and those who have watched our previous diesel videos know that for diesel engines, this is one of the main systems that everything relies on. Without injection, a diesel engine doesn't go anywhere and doesn't even start. Let's begin from the start. You have fuel in the tank, and there's a lift pump in the tank providing about 1 bar of pressure, so it doesn't really play a crucial role. The main pump solves everything. In this case, it's located under the driver's seat beneath the floor. There you'll find a filter and the main pump. If your main pump fails, it provides 3 bars, by the way. If it dies, the car won't start or go anywhere at all. This particular model, the E39 pre-facelift, has the fuel filter located under the hood, whereas in the facelift and later models, it's under the driver's seat. If your lift pump in the tank fails, then there are 2 scenarios here. If you have more than 15 liters in the tank, the car will start because the high pressure pump will be able to pull the fuel normally. If you have less than 15 liters in the tank, the car won't start, even with the high pressure pump. Near the high pressure pump, there's a fuel filter. With our current fuel quality, especially during wartime, it's recommended to change the fuel filter with each oil change, as the fuel now can contain all sorts of contaminants with impurities and particles, sometimes from old barrels or during fuel transfers. It's unclear where it came from. It's recommended to replace it with every oil change. Next, the fuel goes to the high-pressure fuel pump, commonly known as the HPFP. It's mechanical and is driven by the engine's chain. It generates around 300 bar even at idle. There's a fuel quantity regulator on it, which is normally open, but it can close if pressure in the rail needs to be reduced. After that, the fuel goes to the rail, where there's a pressure sensor and a pressure regulator. The pressure sensor shows the ECU, the electronic control unit, how much fuel pressure is currently in the rail. The pressure regulator adjusts. This is the main fuel pressure regulator. If it were to be disconnected and fails, all the fuel would flow back, pressure wouldn't be generated, and the car wouldn't start. For example, if your car suddenly doesn't start, then one of the main options is the fuel pressure regulator in the rail. The high pressure fuel pump lasts a long time. Over time, the gaskets in it may start to leak and it may lose efficiency. I think this happens after about 300,000 to 500,000 kilometers of mileage. Usually there are no problems with the injectors, but it's clear that with mileage they may need refurbishment or replacement. Often, refurbishment may not provide the desired effect. That is, the corrections don't really align. There are many questions regarding refurbishment, so one inexpensive option is to swap in an injector from a scrapyard that is in good condition and provides normal corrections. Now let's move on to the ignition system. Here we have a diesel engine, so there is no ignition system. There is only a glow plug system, which preheats the air in the combustion chamber before starting. It involves the engine control unit plus the glow plug relay and the glow plugs themselves. If there are any issues with them, all the glow plugs and the relay are changed at once. This way you don't have to worry about which glow plug or which relay is the problem. Everything is replaced as a set and forgotten about. The system is designed for cold weather. Depending on the engine control unit modification, there is different operation logic. It works roughly like this. When the temperature is lower in Celsius, the glow relay is activated for a longer heating time. This means the air in the combustion chamber is heated more. I think you understand why it's important to preheat the air in the combustion chamber. This is because a diesel engine operates without ignition. It works on compression. Preheating is necessary for the ignition of the fuel-air mixture to occur. It is necessary to create a certain pressure and temperature. Therefore, without glow plugs, it is almost impossible to start the engine in sub-zero temperatures. If everything is fine with the glow plugs and this system is working properly, but you still have difficulty starting the engine in winter, then there are a few options. One of the main ones is low compression, which may have developed over time. The second could be a problem with the fuel system. Now let's move on to the coolant system. As you know, diesel engines are less thermally stressed than gasoline engines. Therefore, there are fewer problems. The advantage of diesel engines is that they don't use an electric pump, unlike the new gasoline engines like the Nikolai 55. Overall, the weak points here are as follows. The tank is usually fine, and the hoses are generally okay. However, I remember that with Eurobliss, the main hose that goes from the radiator to the intake sometimes breaks. Additionally, the most problematic area for diesel engines in this whole lineup is the flange under the intake. It's a plastic piece that connects to the cylinder head. It can crack and start leaking. To replace it, you need to remove the intake. It is recommended for those who drive long distances to check it, and better to replace it with a new one. I remember a case a couple of years ago where a client's tank broke. It usually doesn't break, but when it did, it turned out that there were no analogs available. And it's only available as an original part, which is quite expensive. And if it is only by original, it means that it does not usually break. But that was just one case. Another weak point in the cooling system is the thermostat. In winter, you'll feel this quite well. If it gets stuck in the open position, you might be driving while the temperature won't rise at all, meaning you'll be in the cold zone with a cold heater. Alternatively, when accelerating to a good speed, the temperature might even drop. This requires replacing the thermostat. There's also the water pump. The pump usually doesn't break and lasts a long time, but of course at such mileages it can start to leak. It's inexpensive since it's mechanical. Considering the age of these cars, you shouldn't be surprised if a rubber coolant hose bursts or wears out or something similar. That's just due to age, and I wouldn't categorize it as a specific issue. Additionally, the radiator can become clogged, or the honeycomb structure can sag or bend over time. The plastic itself can also crack. Well, after 20 years, just imagine, the plastic can easily crack. This is especially true when you touch the flanges, or due to aging, or in areas where the aluminum and plastic are joined on the radiator. Something might separate or crack. So you can consider this a consumable at this age. There's also a viscous coupling which is attached to the pump. You know, at this mileage it may also need to be replaced. But don't be surprised, this isn't a common issue. There are also heater valves in the cooling system. They regulate the air ventilation system in the cabin, which is part of the heating system. These can also break. However, as Sergei Beko tells me, his acquaintance had heater valve issues with a 3-year-old Renault, so it's not worth discussing too much. Also, a component that isn't directly related to the cooling system, specifically for the E39, is the cabin blower motor. It's located inside the cabin and is a common part that fails. Without it, winter conditions can be very uncomfortable. Well, regarding other models, this doesn't apply at all. After the cooling system, let's move on to the engine mount. Everything is standard here. Nothing breaks. Everything is great. Of course, at this mileage, the power steering pump itself might fail. It's part of the engine mount that connects to the air conditioning compressor, rollers usually. This is recommended at around 100,000 to 150,000 kilometers of mileage. It's advisable to replace them along with the belts. Overall, everything is fine. Everything is great. The engine is diesel, so the mounts last a long time. The vacuum pump can also be considered part of the engine mounts. As you know, there is no throttle in a diesel engine, so no vacuum is created in the intake manifold. However, the braking system requires vacuum. Where do we get it from? The vacuum pump is used for that purpose. It is reliable and everything is fine. Of course, at some mileage, it may need to be replaced. Now, regarding chip tuning for such an engine, it's not really relevant anymore. As I mentioned earlier, the standard power threshold here is around 230 to 240 horsepower, if everything is ideal. If you want to achieve around 270 to 280 horsepower, or even 300, then significant modifications will be necessary. This involves using the fuel system from those cars that are next to it, specifically from the M57N. You'd need tuned turbochargers. In theory, if you swap the high-pressure fuel pump, injectors, and the entire fuel system, along with the turbocharger, you could achieve around 270 to 300 horsepower. However, this is associated with a lot of hassle. Given the age of these cars, there are already few enthusiasts willing to invest that much money. Although we do have one in Kyiv who put about $20,000 into his E39. We, by the way, were thinking of filming it before the war. And if you're interested, write in the comments E39 plus $20,000 in tuning and so on. Summarizing in general about this modification of M57. You could say that if you had a car from scratch, I think that after 450,000 kilometers, apart from regular maintenance, like basic roller replacements and maybe some minor issues like a gasket, you wouldn't need to dive into it too much. And here in our year 2024, it's unclear what the actual mileage is on these cars, whether they are cheap European cars with no customs clearance or not, and what the situation is with them. It's possible that the mileage was rolled back in Lithuania or Poland. So at this point, it's less about the year and more about the condition of the car itself. You need to check things like where it leaks, its overall state, how it drives, whether it smokes or not, and so on. And that's, well, make a decision whether to buy or not. Now we move on to the newer modification of the M57 engine. Specifically, this is the car of our manager. Here we have the M57N2. If we go through the timeline of our discussion about the engine, one of the key differences from the previous modification is that this one has an aluminum block, whereas the previous one had a cast iron block. It also features a different connecting rod and piston group. The volume has slightly increased, but it's still 3 liters, just like before. The chains are also different. There's an interesting question regarding the chains. In these engines, the M57N and later versions, it is recommended to replace them after 300,000 kilometers because they are more prone to stretching. And by the way, this isn't such a rare procedure at our Kyiv service centers, since these engines are already approaching and exceeding that mileage. As for gaskets, seals, and oil strainer cups, everything remains unchanged here, similar to the previous version. Moving on to the intake system, one of the key differences is the turbocharger. In the previous version, we had vacuum control for the turbocharger, meaning vacuum went to a pressure regulator and then to the actuator, which adjusted the geometry. Here, we have electronic control for the turbocharger. There are no vacuum systems or regulators. Instead, there's a servo drive with a lever that directly adjusts the geometry as needed. It operates based on what the computer commands, which is a big plus for reliability. But if you have a question about it, there's a nuance. This part is not sold separately from the turbocharger. So you either have to look for a Chinese aftermarket part, find a used one from a dismantler, or figure out another solution. We also forgot to mention an important detail in the system. Intake air supply. This is the crankcase ventilation valve. It regulates the crankcase gases to maintain the correct pressure in the crankcase. Plus, it separates the crankcase gases, which usually come with oil. It filters out the oil from the gases to prevent high oil consumption, returning the oil back to the crankcase. As a result, cleaner crankcase gases enter the intake. But they are not completely cleaned. So you always have an oily film at the intake. Through the turbo, intercooler, intake pipes, and the intake itself, there's an oily residue. Regarding the pipes, intercooler, throttle valves, and EGR, everything is pretty much the same here. There are some minor differences in the fuel system. The main supply pump is absent here, meaning the pump in the tank that provides the correct pressure so the mechanical fuel pump on the engine can properly draw in and build pressure in the rail. There may also be slight differences in the configuration of the sensors, particularly with the regulator and the rail sensor, but those are minor details. Plus, completely different injectors are used here, with a different power rating. This is what I mentioned earlier about being able to transfer this system there and potentially tune it to around 300 horsepower. Overall, the reliability of the fuel system is very good here. It can use either conventional electromagnetic injectors or piezo injectors. In terms of reliability, it's clear that electromagnetic ones are more reliable and easier to refurbish. However, piezo injectors can also be refurbished. There's also a difference in the fuel pump. For piezo injectors, the pump is less powerful because piezo injectors are faster. They open more times per cycle than electromagnetic ones. Thus, they require less performance from the fuel pump to create lower pressure in the fuel rail. Regarding the glow plug system for BMW drivers, everything is pretty much the same. There are no significant issues or differences. There is a small upper thermostat that is always present in the cooling system, near the EGR, So in those earlier modifications, it's not present. Then with the M57N, they start to be included. And here they are present as well. So it can crack or leak, and it may also be replaced along with the main thermostat. Additionally, the main issue here is the flange under the intake system. A newer coolant reservoir and a newer cap are installed here. It is recommended to replace such a cap every 2 to 3 years. Another difference is that the viscous coupling is absent here. So there is less load on the pump, and there is an electric valve installed here. So this reduces one problem. After the exhaust system, there are differences here. A full DPF, diesel particulate filter, is more often installed. So it's like a small tank. First there's a catalyst and then a particulate filter. There are already pressure differential sensors installed in the particulate filter. This way, you can check the pressure differential in the computer to see how clogged it is or not. If there is a problem with the particulate filter, well, everything is pretty much the same here. Usually all of this is removed. A chip is made for the emissions, and everything runs fine. Regarding chip tuning for power, the limit here is about 280 horsepower on stage 1, on a stage and a half if all the emissions controls are removed. But here the fuel system is capable of about 300 to 310 horsepower, and if you install a modified turbo, then you can boost the car to about 300 horsepower. 300 horsepower on 330 diesel, on a diesel that's economical. This is no joke. This is already at the level of 335s and 535s from the BMW F series. And here we move on to the most powerful top version of the M57 engine. I think every BMW owner will be glad to hear about this, as they understand how reliable it is and what a great potential it has. We're going to talk about how much it can be tuned. Let's assume this is a stock car. This is an E91, a 335i. And it seems like this car is 325i, and here we have the 335i. So ideally, the internals should be different. But we even checked the VIN codes and compared them just for curiosity. The crankshafts are identical. The same crankshaft, the same connecting rod, can you imagine? The connecting rod piston group is almost entirely the same, except for the pistons. Here, we have a slightly different compression ratio and different pistons. I believe they are stronger than the ones in the 325i. But the connecting rods and crankshaft are the same. That's already interesting. This engine also features an aluminum block. Everything else in terms of hardware is pretty much the same. The chains must be replaced after 300,000 kilometers of mileage. The most significant changes here are in the intake system. As we can see, the engine bay looks entirely different. The air filter is located in a different place. There's a different mass airflow sensor and other hoses. And that's where it gets really interesting. Where the turbocharger is located, there are 2 turbos, twin turbos. It has a very complex system with 3 actuators. One vacuum actuator regulates the valve between the big turbo and the small one, depending on the load conditions. The third vacuum actuator regulates the bypass valve at the intake. It controls where the air goes. So compared to those other cars, there's an important nuance here. If you have normal mileage, you should definitely replace all the vacuum hoses. It's advisable to install new pressure regulators as well, because if you have any boost issues, you need to address that comprehensively first. By the way, here in Lviv, at the turbo service we have rented, we even have a variety of new and used valves available for BMWs. This is to quickly replace them and check their functionality. As for the injection system in diesel engines, it's straightforward. If you have a different turbocharger, you'll need different injectors. This car is no exception. It has different injectors. Interestingly, the fuel pump shares the same part number as the one from the previous model. There's nothing particularly significant that commonly breaks in the fuel system. There are no significant issues with these systems. Everything is great and reliable. The coolant system here is the same as on this E91. There are no significant differences in the accessory systems. When it comes to chip tuning, things get quite interesting. Because in stock form, this car is equipped with powerful components that are ready for significant modifications. Even without replacing the turbos with hybrid ones, European versions come with around 286 horsepower. The pre-facelift E60 has about 272 horsepower, while the American E70 is limited to 252 horsepower due to the AdBlue system. I mentioned this before. By the way, a couple of years ago, we had a post on Instagram about an E90 335d diesel that we tuned to about 330-340 horsepower, which dropped the 0-100 km/h time to just 1.5 seconds off the line. So there's a substantial increase in performance for American models when we remove the AdBlue system and do a chip tune. European models see a smaller increase because, as we know, they start at 286 horsepower, while the American versions only have 252. So if we take such a version and remove all the emissions controls, we can easily achieve around 330-340 horsepower. For instance, if we recall the 335, the E90 diesel that our friend raced, it really showcased the potential of these modifications. Now we're going to show the video, and we successfully pushed it with the F30 328 Stage 3 project. By the way, it was already at Stage 2 back then, equipped with a custom tune and an intercooler. On the dyno at Dark Horse, it produced 353 horsepower, as far as I can remember at the time. Those are the limits. Usually it's said that you can achieve around 360 to 370 horsepower if you push it further, but with stock turbos. But that's all nonsense. The dyno showed 352 horsepower on Stage 2. Do whatever you want. I'll allow you to play around with water methanol. As for this particular unit, the owner is an IT specialist from Kyiv. He works at Luxoft, by the way, which is a company located near us on Berestayska, where I worked for a few years, and he decided to get serious and wanted to modify this to over 400 horsepower. What did he do for this? In terms of main modifications compared to stock here, we have a Stage 3 turbo setup, 2 upgraded turbos. The fuel pump has been replaced with a more powerful one. The stock injectors are still in use. All piping has been upgraded, and the intercooler has been replaced with one costing over $1,000. Upgraded vacuum hoses like silicone ones. And the firmware has been changed. The owner has, of course, been struggling with it for a long time. He has already replaced the pressure regulators and the pressure sensors in the fuel rails, but the coveted 400 plus horsepower is probably achievable here. However, the car has not been on the dyno yet. With this configuration, 400 plus horsepower is possible and realistic. He wants to replicate that. Currently, the car is in the process of breaking in, tuning, and modifications. It hasn't been on the dyno yet, so wish the owner good luck. We hope to have another fast project in Ukraine, a diesel one with the M57, which will show that the M57 is a great engine, even without significant investments and changes. And most importantly, all of this is on the stock components of the engine itself, the connecting rods, the piston group, and the aluminum block. I just thought about it. If this is a diesel engine that can make 400 horsepower with fuel consumption in the city, roughly speaking, 7, 6, 7, 8 liters, and on the highway around 5 or 6. So, considering that we currently have a problem with fuel, a problem with gasoline in the country, this is a great alternative to various Stage 2, Stage 3 setups, the N55, N20, and similar options. So I'm starting to think, maybe we should film this car for a project. Let us know in the comments who is interested in such a project. We could make a full video when it's fully operational and ready to perform well. We can also record some dyno runs. In general, we could create a cool video about diesel. And if you feel like the information we've provided in this video isn't enough, and you have some free time with nothing to do, and you want to ask us additional questions, look, we have Dmitriy, our manager, who is from the main station in Kyiv on Berestayskaya. We've temporarily relocated him to Lviv while we establish our processes and work here, and behind us is his beautiful Turin. You can call the Lviv phone number. Ask questions. Dmitry will kindly explain everything to you. The price is, I say, $1 per minute. It's available. What conclusions do we have about this engine? In short, over 500,000, everything is good and in order. But the question is what mileage you'll find, whether it's real or not, and plus the cars are already around 20 years old. I can still find decent, fresh examples with honest mileage and without any problems. The main recommendation here is the timing chain. After 300,000 kilometers of mileage, it's a must. The main conclusion is that the engine is superb. It's no wonder it won Engine of the Year several years in a row, and it's no surprise it has so many powerful and less powerful modifications. We definitely give it a thumbs up. If we were in the year 2010, for example, or 2008, this would probably be the most top-tier, coolest engine in the entire BMW lineup. Of course, now we're in 2024, and time flies. BMW is making other cool engines, so there's already competition. Plus, these cars are becoming outdated, and unfortunately, you won't see a fresh G-Series or F-Series car with this engine. But there's no need to be discouraged. If you want to buy a BMW from the F or G Series, you can find various videos on our channel reviewing different engines that are newer than our M57, and you can make a conclusion about which engine is best for you, what body style is better, and so on. So, give our channel a thumbs up for the content and subscribe to our Instagram, where we share interesting information and stories earlier. Don't forget, there is a war in our country. Support the armed forces of Ukraine. So glory to Ukraine, death to the occupiers, and we're off to work.